Today we're going to look at the geometry of a parabola. So if you recall from last year in geometry class with Mr. Sharp, you did something called locus, which is finding all the possible points that satisfy a given condition. Believe it or not, a parabola is actually a locus, and it is the location of all points that are equidistant or the same distance from a fixed point called the focus and a fixed line called the directrix. Take a moment, pause the video, record this definition, and draw yourself an XY axis so that we can make a picture of this definition. So I'm going to pick a point that's going to serve as our focus. I'm going to do it in red. Here's my focus. I'll put it right on the y-axis. I'll label it F for focus. And then I'm going to pick a line that's going to serve as our directrix. I will do that in green. And I'll label this as D for the directrix. So our definition says that all the points of the parabola should be the same distance from the focus and from the directrix. So if you think about it, one point that should be fairly easy to find is what's going to be the turning point of our parabola. It's going to be halfway between the focus and the directrix. So right here is going to be our TP, or our turning point. Now I'm just going to sketch in a parabola here to show us the idea of all of these points. So if I pick this point in blue on my parabola, the distance from the focus to that point should be the same distance from that point to the directrix. This and this have to be the same. Up here, this point in green, the distance between that and the focus should be the same distance between that point and the directrix. And even over here on the left side of the turning point, this point in red, this distance should be the same as this distance. So far in this class, we've written equations of quadratics or parabolas two different ways. One, given the zeros, we can go backwards and write the quadratic equation they came from. Or if we're given a set of points that seem to form a parabola, our graphing calculator will do the regression to give us the equation. We can also write an equation of a parabola if we know the focus and we know the directrix. The easiest way to do that is using this formula, x minus h quantity squared equals 4p times y minus k. Now there's a lot of letters in there. H and k, what those are the coordinates of the turning point. The p in the formula is the distance between the focus and the turning point. And the x and the y are just going to serve as our two variables in the equation. They'll just stay x and y. So let's say we want a parabola whose focus is 0, 4, and the directrix is y equals negative 2. So let's sketch ourselves a quick little graph here. And I'm going to make some tallies here on some scaling on the x and y on the y-axis so that we can mark these off. The focus is at 0, 4. There's my focus in red. And then my directrix at y equals negative 2 is down here. So ask yourself, how far apart are the directrix and the focus? Well, it looks like they're 6 apart. So halfway between those 6 will be at a distance of 3. So 1, 2, 3. So we now know the turning point of our parabola is at 0, 1, which means we know h and k in that formula. So I'm going to plug in h is 0, k is 1. Now the only other thing I need is the p, or that distance between the focus and the turning point, which is a distance of 3. So I'm going to plug in a 3 for p. And now let's just simplify this a little bit so that we can get our equation to be y equals. Over here on the left, x minus 0 is x, and then you square that, you get x squared. 4 times 3 is 12, times y minus 1. Now you might be thinking, oh, let's distribute the 12. I'm actually not going to do that. It'll actually make our lives easier if we divide both sides by 12 to get rid of it. So that'll leave us x squared over 12 equals y minus 1. And then to get the y by itself, I'm going to add 1 to both sides. So my equation is going to be x squared over 12 plus 1. So my parabola will look something like this on my graph over here, so that every single point along that parabola, like this one right here, is the same distance away from the focus and the directrix. We'll try one more. Now we want to focus at 0, negative 3, down here, and our directrix is at y equals 1. So there's my fixed line. Now my turning point should be halfway between the focus and the directrix, which will land us right here at 0, negative 1, which are going to serve as my h and my k. So plugging the h and k into my formula, x minus 0 squared equals 4p times y minus k is negative 1. Now notice the minus negative 1 is going to turn into a plus a positive 1. And my p, that distance between the focus and the turning point, is a distance of 2. So I'm going to plug a 2 in for p. And now let's simplify. X minus 0 squared is just going to be x squared. 4 times 2 is 8, times y plus 1. If we divide by 8, we can get rid of that. That'll leave us y plus 1 equals x squared over 8. And then subtracting 1 from both sides, we're going to get x squared over 8 minus 1. Now, one thing to be careful of here is that our parabola is not going to be going up because it cannot cross over that directrix. So our parabola is actually going to be going down in this case, which means my x squared needs to be negative. So essentially the definition of the parabola is worse than actually writing the equation of the focus and the directrix. If you know the vocabulary and you know the formula x minus h squared equals 4p times 1 minus k, you should be good to go.